So again, I start the problem by making a drawing of it so I can start seeing what else going on in this situation. So it's a cylindrical tank. So yes, you got to be envisioning a cylinder like this. So like it could be a can or something like that as well, that sort of a picture. We know that the tank radius is going to be 20 centimeters. So I'm going to go ahead and label that on my picture. And we want to know how fast the height of the water in the tank. So that's going to be like this height of my water in our tank there drops when the water is being drained at 25 cubic centimeters. So it's being drained out of it. You know, they put a hole in the bottom or a hose and then they're draining it out at 25 cubic centimeters. Oops, should be cubic there, per second. Now this thing is full of water and we're looking to see what's happening as we're draining out that much water. You notice that our water here, it is measured in cubic centimeters per second. So that's a big clue about what type of equation you're going to have to write here, because cubic centimeters is a measure of volume. And so that should be telling us then that I want to be writing a equation here for the volume of a cylinder, and that's going to be what I end up using in order to be able to solve this. Now, hopefully you remember the equation for the volume of a cylinder. If not, you could always look it up. The whole idea is that any kind of a shape, be it a cylinder, a prism, anything like that where you have some shape that's just been lifted straight up, it's always going to be the area of the base times the height. So in this case, our volume then, the area of the base, that's the area of a circle, is pi r squared. And then that is being multiplied then by the height. So there's the volume of a cylinder there. Now at this point, we actually can go ahead and just start by finding the derivative with respect to time on both sides. Now, of course, on the left side, the derivative of v is just going to be dv over dt. On the right-hand side, pi is a constant, so we know that the pi is still going to be hanging out front. But you notice that's going to be r squared times h, so we're going to be using product rule here. In my mind, as I look at this for you doing product rule, I'm seeing it as the pi r squared, that's then being multiplied by the h. So I do the original, so that's the pi r squared, times the derivative of h, which is dh over dt. Plus, now I'm going to do the derivative of pi r squared. So that's going to give me 2 pi r, don't forget the dr over dt there, times h. Now that we got all those pieces, we want to start plugging in any values that we know. Do we know what dv over dt is? Yes, we do. But it is not 25, it is negative 25. Because remember that we are reducing the volume by 25 cubic centimeters per second. All right, then pi is pi, of course. The radius we know is 20, so that's going to be a 20 squared there. And then dh over dt, that's actually what we're trying to figure out here, is we're trying to figure out how quickly is the height of the water changing. That's dh over dt. All right, so then plus 2 pi, again, put the 20 in for r, and then times dr over dt, and then times the h. But what is dr over dt? Well, that's how quickly the radius is changing. This is a cylinder. In a cylinder, it's the same circle going all the way up, like you took the same circle and stacked it above itself. And so the radius is always the same. The radius is always 20 centimeters, no matter how high the water is. Therefore, dr over dt is 0. Now, we actually don't know what h is, but notice we don't have to, because I'm going to be multiplying that by 0 in a moment, and it's going to go away. All right, so if I simplify this down, the whole equation now just becomes negative 25 equals 400 pi dh over dt. All right, now solve for dh over dt, which I can get exactly as a negative 1 over 16 pi, or get a decimal approximation of negative 0.01989, or in other words, about negative 0.02. Now, again, let's take a look at the units here. It might be tempting to think that it's going to be, for instance, maybe cubic centimeters per second. After all, that's what we had right over here, right? But it's not going to be that, because notice that it's dh over dt. H is just the height. My height is just centimeters, not cubic centimeters. So your unit then should just be centimeters per second.